Hello everyone, welcome back to the channel. Are you ready for today's content? When you think about the future of robotics, what comes to mind? Probably a few huge names, right? Like Tesla, Google, maybe Boston Dynamics. It's easy to picture these giant billion-dollar companies tucked away in secret labs, crafting our future behind closed doors. But what if I told you that whole picture is missing something way more interesting? Because right now, there's this massive global rebellion happening. It's kind of quiet, It's being fought in university labs, in these scrappy little startups, and by individual developers all over the world. And what are they doing? They're releasing the literal brains for advanced robots. And they're doing it completely for free. This isn't just some small trend, folks. This is a huge, fundamental challenge to the entire robotics industry. So, at the very heart of this whole thing are what's called a VLA models. That stands for vision, language, and action. Think of it like this. This is the AI brain that lets a robot actually do stuff. Vision is how it sees the world around it. Language is how it understands what you tell it to do. And action, well, that's it actually doing the physical task. And here's the crazy part. These open source VLA models, they're now just as good, and in some cases, even better than the secret, expensive tech the big guys have. Okay, so who are these rebels exactly? Well, it's not like one big unified army. Nope. The movement is actually made up of 4 totally distinct groups, or factions, and each one is pushing this new robotics arms race forward, but with their own playbook, their own strategies, their own goals. And if you want to understand what's really going on, you've got to understand these 4 factions. All right, here they are. First, you've got the academic underdogs. Then, believe it or not, the tech giant ecosystems. Yep, the big guys are in on this, just not in the way you'd think. Third, we have the startups and innovators who are all about pure, raw speed. And finally, this really interesting group called the technical extremists. So let's break them down one by one. First up, let's talk about the academics. These are the folks in university labs and research centers. Now, they don't have anywhere near the kind of money that a Google or a Tesla can throw around, so they can't win by outspending anyone. Their only way to win is to be smarter, to be more efficient, and to come up with way more clever designs for their AI. And this is a straight-up David versus Goliath story for real. So you have Google's monster model, the RT2X. It's got 55 times billion parameters. You can just think of parameters as, like, the number of knobs an AI can turn to learn stuff. And on the other side, the open source model, OpenVLA, with only 7 billion. And guess what? It won. How? Its secret sauce is this really clever dual vision system. It has one part of its brain for knowing where things are in space, and another part for understanding what those things are. It's just smarter, more efficient. And that's their superpower. This group also came up with models like Octo, which is kind of like a Swiss Army knife AI that you can basically plug into any robot and have it work right away. All right, now let's talk about the tech giants. You'd probably guess they'd just lock everything down, right? Keep it all secret. But they're playing a much, much smarter game. They totally get how powerful the open source community is, and they're trying to use that power by building their own private playgrounds around these open models. NVIDIA is the absolute master of this. They have this strategy called Open Brain Closed Gym. It's brilliant. They give away these powerful base models, like GR00T, for free. That's the open brain. But if you want to properly train that brain, you have to use their closed proprietary simulation platforms like Omniverse. See? It's that classic give away the razor but sell the blades move. Google's doing something similar too. They used to be more open, but now they're trying to build the Android of robotics with their more locked down Gemini platform. Okay, faction number 3. This is where you find the pure raw speed, the startups and innovators. These teams are all about moving at lightning speed. They're iterating like crazy, and they are laser-focused on solving real-world, practical problems, like how to make robots react faster and how to make software work on all different kinds of hardware. And you can see this in a couple of really brilliant solutions. Take Xiaomi. They get robots to react in milliseconds by splitting the AI's job. There's a big brain model that does all the heavy thinking, but then a smaller, dedicated cerebellum processor just handles the instant physical reflexes. So smart. Then you've got other startups like OpenMind tackling a huge headache. Basically, every robot speaks a different language. So they're building a universal translator, an open source software that acts as a bridge so you can write code once and have it work on tons of different robots. And that brings us to our last group, and maybe the most intense of them all, the technical extremists. For these folks, all that stuff about general intelligence, that's nice, but it's not the point. They have one goal and one goal only: perfect, fluid, absolutely precise physical movement. The big name here is a company called Physical Intelligence, and their model is Pi Zero. Now, think about it. Most AI control signals are kind of clunky, like a light switch. It's either on or off. But Pi Zero uses something called flow matching, which is more like a dimmer switch. It creates this smooth, continuous flow of control signals, and that lets the robot do incredibly delicate things like folding laundry. And their business strategy is just as clever. They give the model away for free, hoping it becomes the industry standard. But they keep their real secret weapon, all their unique training data, locked up tight. So let's just do a quick recap of these four factions. You've got the academics winning with efficiency, the tech giants winning with their ecosystems, the startups winning with speed, and the extremists winning with pure precision. And they're all playing the game differently, from totally open to these clever hybrid approaches. It's this variety that makes this whole thing so exciting. Okay, so you might be thinking, this is all cool, but can any one of these groups really beat a monster company like Tesla that does everything themselves? And honestly, the answer is probably no. But here's the secret weapon. They aren't working on their own. The real superpower of this whole open source movement isn't just one model or one group. It's how three key things come together and multiply each other's power. The real magic, the real power, comes from the combination of three things: open models, shared data, and accessible tools. When you put those three together, they create this incredible flywheel effect. It's like this compounding innovation that just gets faster and faster. No single company, no matter how big, can keep up with that. So it's not about one little model beating a giant. It's about an entire ecosystem outrunning them. So let's look at the data part. The crown jewel of the whole community is this thing called the Open X-Embodiment dataset. Get this, more than 20 of the best labs in the world all pooled their data together. They created this massive library of over 1 million real-world robot actions. But here's the really important part. That data comes from 22 totally different kinds of robots. And it turns out having all that variety is actually more important for training a smart, adaptable AI than just having tons and tons of data from only one kind of robot. And the last piece of this puzzle is the tools. And this is where it just gets mind-bending. Okay, so training a robot in the real world is super, super slow. But check this out. There are open source simulation tools like the Genesis engine that can cram 49 years, yes, years, of real-world training experience into just 1 hour. And we're not talking about some government supercomputer. This runs on a regular gaming graphics card you could buy online. This just blows the doors wide open for anyone to get into robotics. Okay, but let's take a breath here. We have to be realistic. It's not all smooth sailing and perfectly folded laundry. If we're going to get the full picture, we have to talk about the huge, real-world challenges this whole open source community is up against. There are 4 big ones. First, just the cost of computing. Training these amazing models still takes really expensive hardware, which locks a lot of people out. Second is data quality. Yeah, the open data is diverse, but it's not always as clean and perfectly labeled as what a big company can make. Third, there's the engineering gap. I mean, it's one thing to make a cool demo for YouTube, but it's a whole other world to manufacture a reliable product that doesn't break. And finally, the biggest one of all, physical safety. Look, when ChatGPT hallucinates, it writes a weird poem. When a 200-pound robot with a gripper arm hallucinates, that can be really, really dangerous. Safety has to be priority number 1. So even with all these massive challenges, it feels like we're in this incredibly unique moment. It's like a golden window of opportunity, a time of fair competition where the entire future of robotics is actually being decided right now. Because this global scattered network of developers is sharing models, pooling data, and building these amazing tools, they are speeding up the timeline for getting real general-purpose robots into our world. The next huge breakthrough, it might not come from some secret corporate lab after all. It might just be built out in the open by this huge, messy, brilliant, collaborative global network with everyone pushing the boundaries together. And so that leaves us with the one big question, right? When we look back on this time years from now, who are we going to say built the future of robotics? Is it going to be the giant billion-dollar megacorps working inside their walled gardens? Or will it be this sprawling, sometimes chaotic, but incredibly powerful global network of developers? The race is on, and it's going to be fascinating to watch. Thank you for watching. If you enjoyed this video, don't forget to give it a thumbs up and subscribe to the channel. See you next time.